Hey everyone, welcome back to Tech Junior Tutorials. My name is Lee Warwick Jr. and we are talking about Advent Code. Today is the 27th, but we are going to be talking about day 23. Today is, or day 23 is an int code problem. So there's been a whole lot of those so far, almost one every other day, but they've been really interesting and very varied. They've been pretty diverse from day to day, despite working with the same type of problem. So the int code computer itself has been done for quite a while, ever since I think day 9 it was complete with all the operations. But each new day that we use it, we're finding some new fun way to solve a problem with it, or the creators of Advent Code or Creator, I don't know if he has any help, but finds a new program that he can write with an int code array, right? So let's jump into this problem and take a look. So I'm almost at day 25. I finished 23 and 24. For 23, it is category 6. It talks about you've got a Cat6 network cable. It's been a long time since I've been in high school, like 10 years or so, but well, gosh, how long has it been? Let's not talk about that. But back when high-speed internet came out, I remember these as Cat5 cables. I didn't even know there was a Cat6 cable. But anyway, not to digress. We're running on an int code computer. They say that we've got some kind of computer system that has crashed, and it has a network of computers. And so each computer is an int code computer, and our job is to run a copy of the NIC software that is the input to this. So if we scroll down here and look at the input, this is the input for it. It is a ton of numbers. This is one long list of numbers that is what int code is actually running on. So this just blows my mind every time we do one of these int code problems and I see what this is, and like once we solve it, seeing like what it does is just amazing. So what we're supposed to do for this is essentially, they tell us that we've got to do int code for 50 computers. And the way that this is written, if you remember back, or if you haven't watched, I believe on day 6. Nope. It's going to make a fool out of me. 7. Okay, so on this day, we had to run 5 int code computers at the same time. Well, supposedly at the same time, but basically, like A was supposed to run, and that would output to B, B would output to C, C would output to D, D to E, and E would output to A. So these would run in a loop. And the second part was to like run them in a giant loop over and over and over again. But for today, we're going to run 50 different int code computers at the same time. And they really throw out there that they're not supposed to be blocking. So if you're a JavaScript developer, then you're probably familiar with synchronous and asynchronous code. JavaScript has a lot of neat ways to get around blocking behavior, even though it's single-threaded. Meaning, like, so if you write a for loop that goes from 1 to 1,000,000, the whole program is going to halt because that is a blocking operation. But if you do like a network request, that's an asynchronous operation. So we have things like callbacks and promises and stuff like that that will defer that behavior. I don't know if Python has anything like that. I know that you can do multi-threading in Python. I haven't done it, and I didn't do it for today. So I took a gamble and said, like, I think that this can be done without multi-threading, and I was lucky enough to be right. But yeah, so they kind of throw out there and say, like, hey, this is supposed to use multi-threading, but I didn't. I wrote it in a way that I kind of cheated and didn't do that. Maybe it would have been simpler with multi-threading. I'm not really sure. But I didn't want to sit down and learn that for this one puzzle, even though, like, in the spirit of learning is why I'm doing this, but I didn't want to kind of dip into multi-threading today. So back to the problem. What this is asking you to do is it's saying that you've got 50 computers running at the same time, and they can take in input that's supposed to go into a queue or a buffer, and they will read from that queue, and they're supposed to be able to read from it constantly because they're all supposed to run at the same time in parallel. And if the queue is empty, so if they're not receiving any information, you're supposed to give it a -1. Otherwise, they're supposed to receive values in sets of 3s. Well, I'm sorry. They're supposed to receive 2 values, so an x value and a y value, x, y, x, y, x, y. And they're going to output 3 values at a time. So they're going to output the address of the computer they're supposed to send to, and then an x and a y. So it's a really interesting problem, especially using int code. It really depends on how well you were able to write an abstraction for your int code computer. I was lucky enough that I wrote mine as a function that takes inputs or arguments that would allow me to tell it how to behave. So if we look at my code, this is my category 6 solution. I've got my int code and my get inputs code up here. So you can see from my int code problem or function, I've got a helper function for get inputs that parses the parameters. So if you get an instruction in int code that is like, where's one? So like that looks, I don't know if my VS Code froze on me. There we go. So that there looks to be an instruction for int code. So that is parsing, so we're gonna do operation 6, and these are like the modes for how it's gonna treat the parameters that come after it, which are 0 and 73. I think this is kind of slowing down because this is a huge array or huge text file. But anyway, so I've got my int code program. The get inputs function is the helper that parses those inputs we just talked about. Int code itself, I've coded it so that it can take that array. It can take a method to use as the input method whenever it needs input, and it can take in a output method that it can use when it needs to output something. So Python and JavaScript are really nice where you can pass functions as arguments, which made this really kind of easy to work with. And then also the optional arguments or default arguments were really good as well. So doing that, I wrote a class that is basically going to call int code as like a helper function. And it is going to be an int code computer because I want to make 50 of these things. I figured it would be really good to write them as a class so that each one could have its own data structures that are available to it. So whenever I create an int code computer class or object or whatever you want to call it, I'm going to give it the program. So it's going to go ahead and make its own copy of that. It's going to get its address and a send function. So like whenever it needs to output or whenever it's done outputting, because remember, this thing is going to output sets of 3 values. So when it gets those 3 values ready, it needs to then send them to the next computer. So I wanted to pass in a function as an argument when I create an int code computer, just like I did up here, that will allow me to do that easily. So all of this stuff, kind of like the previous days, have forced me to kind of think ahead and write better code that can be more flexible like this. So that's kind of one of the things that's been awesome about working on Advent of Code. So that's my init function. The start function is just going to run the int code function, and then if it finishes, I wrote my int code so that, like, if I need to pause it, I will return the index, and so then whenever I restart it, I can pass that index back into it, and it's kind of like it never stopped. So from there, I've got a queue inputs function. So that one, okay, so that is going to be the function that I call to add to the buffer. So each int code that I create has its own buffer. So that's just the list that it's going to pop off of every time that it needs a value. So when encode is running, sometimes it requests a value, and so I want to have those queued up ready to go whenever it needs it. And so I put those into an array so that here's my input method. So if the buffer is empty, remember the problem said it needs to receive a -1. So there's that -1. Otherwise, if it has values, go ahead and pop the next value off the top. Outputter is a little bit more complex. So what this is doing is it is saving values in the order address XY into a dictionary that I have stored up here. So all the logic says is like, if address is none, save that. If X is none, it goes in there. Else, if Y is none, go ahead and save that to Y. And then it says, every time you receive those values, check and make sure if all three are not empty, that means that it's ready to send. And then it's going to call that send function. And then it resets that dictionary. And that's kind of it for the encoded computer itself. It does have some statefulness. It doesn't really use it a whole lot. If you notice, like I don't really check for running anywhere. So that's not a huge deal. It never actually halts. So the programs run indefinitely. So you'd have to kill them manually if you were actually using like multithreading. Otherwise, they do a pause state. So I'm pretty sure I could strip all of the statefulness out of this, and it wouldn't really make a lick of difference because of the way that this program is written, the input program. So that is my getting tongue-tied, encode computer class. Now I have another class that is the NIC class, which is going to manage 50 of those other ones. So for this one, basically all of my logic is living in this init function, so I won't really look at that first. But the way I'm managing all of these encode computers is with a dictionary. So for each one that I create, I'm going to store that with its address as the key, and the actual return value from the encode computer class is going to be the value in that dictionary. Nat is something for part 2. So we'll talk about it in a second. And then done is what I'm using to, I believe, stop this computer. I don't even know if I have self.done in here anywhere. Let me find. I was doing these kind of fast because yeah, so I don't even think I'm using that. Let's get rid of that and see what happens. When you're doing these for speed, yeah, so I don't even need that value. When you're doing these for speed, you're kind of like wanting to get the problem done and not really going back and cleaning up the code as much, which is part of the challenge. But I feel like I've tried to write mine so it's a little bit more readable. I've seen some people that have like this wizard code that is like machine language X and Y and R and A, B, and that's all their variable names. So that drives me nuts and makes the code that you write almost useless if you ever come back to it. So I try and write it a little bit better than that. But in any case, so what I'm doing here is I'm going to loop through 0 to 50 and start or create an encode computer. So whenever these things start, they are supposed to receive as the first value their network address. So for each one, it is going to receive I, which is, like I said earlier, the key for the dictionary. So I don't know if JavaScript can use integers as keys for objects. I don't think I've ever tried to do that, but luckily Python is able to. I will have to try that in JavaScript. But so I start up each encode computer, pass it the address. I pass it this helper function, and I store it to its address in the dictionary. And then I run through all 50 again and start all of them. So what that does is they will all ask for their own network address, and then they'll all get -1 as a value and basically pause. And then I have a loop function. And so what this is doing is a little obtuse, but it is going to loop through basically all 50 computers 10 times and try and start them. So they're going to run and then basically receive that -1 value, run, receive the -1, receive the -1. I don't really know what the Intcode program itself is doing. I'm sure that it's tracking its own state internally as it does all these computations to compute the answer. But what I had figured was that because the problem, well, I don't really know if they give you any hints, but I just had a hunch basically that it would need at least to receive one -1 value. So at first, what I did was up in my Intcode program, under opcode 3, which is the input opcode. So here you see, like, if it says -1, I've changed this a little bit, but before it returned if it received a -1. So it never passed that -1 to the program. And so what that did was basically smash everything and Intcode ground to a halt. All 50 of them stopped immediately. So what I did to fix that was I actually let it receive the -1 value. And what I do is I keep an internal track or count of the pause codes that have been given. So every time it receives a -1, it is going to like add to a variable n for a number of times that it's received a -1. And so I had played with this a little bit, and it doesn't really seem to matter internally how many times it receives the -1. It just needs to receive it once at least to tell itself that it is paused. So I basically played with this value to see if it would break anything. And it didn't seem to. So once I had done that, that got me pretty close. But the second part to this to actually get the answer is that it is going to receive at some point, or output at some point, a value to address 255. So what they tell you in the problem is that at some point it's going to send a value to 255 and they want to know the Y value. So for that, that was pretty easy to do. Basically, once you get it running and everything's going, my send to address function, what that does is it receives those 3 values once Intcode has computed all 3. And so it just checks to see, hey, if you've sent it to 255, go ahead and print, this is the part 1 answer. I added to that a little bit because part 2 talks about what to actually do with that value. But if you run this, you can see it computes part 1 pretty quickly and then part 2 right after it. But so part 1, 26,163. For part 2, it says that you have to receive multiple values to that NAT address. And so for that one, they say if something is going to go to 255, then it is going to be handled by a not always transmitting device. And basically what that does is, so here's where the concurrency comes in. They say that basically NAT is supposed to monitor all 50 computers and wait until all of them are idle. And so when I read that, I kind of thought this must be possible without multithreading. Because it just screamed it to me. I don't even really know how to explain how I knew it, but like this gave me a stronger gut feeling from one, solving the first part without using multithreading, but the second part as well. And so what I did for that is I basically, again, just like for the Intcode computer, I played with a certain value n of times to loop through and try and restart all of the computers. That would cause it to fake being idle, essentially. So I figured if I run all of the computers in series enough times, that would be the approximate like an approximation of them running at the same time long enough to reach whatever state it is that they spit out this nat value. So basically I do that over and over and over again until I receive a double value to y. So the answer to part 2 is, it says, what is the first y value that's going to be delivered by the NAT computer to address 0 twice in a row? So basically with part 2, they tack on that whenever you get something to 255, it is then going to send that to address 0. So it's kind of like an intermediary. I think it's meant to really trip up people that use multithreading. And that makes sense because you would, like, naturally, if you have all 50 running at the same time and multiple of them are kicking off calls to NAT, that would seem to cause race conditions, I would think. But because I'm running mine one after the other, it becomes a little bit less of an issue. I was printing all of the address values as they were coming out of the program initially, and you could see it would spit out like 5 or 6 calls to NAT in a row. So basically, to solve for this, I've got a while loop running, and so I think this is a nested while loop. No, it isn't. I think I had a nested while loop originally. Oh, so this is not a nested while loop. This is a recursive function that I'm calling. So within the init function, I'm calling a recursive function that basically it's going to loop through 10 times, start all 50 computers, and that's going to do a check where it looks at that final value in nat1 or position 1, which is y. So I've stored that up here into the class. But after it goes through a round of computation, or 10 rounds in this case, it's going to look at whatever the latest value to come in to NAT was, and look at the y value, and then it's going to store that into a set. So that is really easily going to let me know if I've ever seen that value before. And as soon as, so I'm checking if it's not in the set, then add it, and then call the function again. As soon as it detects it in those values, bam, it prints part 2. I don't have to force stop anything. I'm basically done at that point. So if you run it, you see it takes a second to run part 1, and then part 2 pops up another half second later. So we can watch the fireworks if we do this. You can see how many computations are actually running in this thing. I don't think I actually print nat anywhere. But there were some cool visualizations of this on Reddit. I thought about doing something in the terminal, but ultimately I wanted to move on to day 24. This is amazing. Like, there's all this math is going on behind the scenes to do this. I believe every time I hit address 0, that is a nat value that's going in. It's pretty wild when you think about what's going on behind the scenes. In any case, 18733, that is the answer for part 2. So this one was really, really cool. I had a lot of fun doing this one. That was a great challenge, especially I felt like I was built up to it from doing day 7, which we talked about at the beginning of the video, which was the amplification circuit or sensor boost or something like that. Amplification circuit, I'm almost sure of it. Where you're running all these encode computers that are outputting to the next one, to the next one, to the next one, back to the first one. This one running all 50 at once and talking to any other computer in those 50. Really cool problem. I feel like it really helped me stretch my legs as far as handling some complex data and storing that data in a sane way, using like data structures and classes and a little bit of object-oriented programming and that sort of thing. So really enjoyed that one, especially coming from day 22 where I was like totally out of my depth working on discrete math. yeah, so that was a great one. Really enjoyed day 23. That's all I got for this one. Like, subscribe, comment. Tell me how you're doing on Advent of Coder if you solved this thing already. And I will see you for the next problem.